Hi, and welcome everyone to the next AI 42 session with Paul. Hi, Paul. How are you?
Hello, fine, and you?
I'm good. Thank you for asking. So, building an architecture dedicated to industrialization of machine learning raises many questions, even more so when different Azure resources seem to play similar roles. So, should we choose between Azure machine learning and Databricks, or can the two interact? So, these are the questions that you're going to answer today.
Yeah.
So, Paul actually works at Avanade as well, and he is a manager expert data scientist and is also a Microsoft AI and data platform MVP. So, Paul, please tell us about your journey in the data and AI field. Like, where and when did you start? What inspires you? What tools are you in love with? And so on.
Okay. So let's go 20 years before before now. I was student and I used to learn the statistics without big data with just one Excel sheet, and was quite different for. Uh, at the moment we have many tools in the cloud, but I keep in my mind some good practices or some ideas coming from the statistics, and now at Avanade, especially, I'm building some architecture in the cloud in Azure, and I'm trying to do it. The more the most I want to find the more simple architecture, because I know that our clients could say there are too many services in Azure. I don't know why. I don't. It will cost a lot, but I'm not sure that there is only one tool for everything. That's what I will explain to you in this session.
Yes, because you're actually bringing on the stage Azure Machine Learning, which we have talked about before at the AI 42 sessions, and Databricks, which was also a tool that we were talking about before. And now you're going to bring these two together and compare them.
Yeah, compare, interact, and compare to see the difference and the right tool at the right moment.
Wow, this sounds really interesting. And I'm going to hand it over to you in a sec, but first, let me introduce AI 42 first. So welcome back everyone. This is the quick introduction about AI 42. So the motivation for starting AI 42 comes from the recognition that there is no good starting material. And AI 42 is a strong team consisting of 3 Microsoft AI MVPs that strive to provide you with a valuable series of lectures that will help you jumpstart your career in data science and AI. AI 42 aims to provide you with the necessary know how that can help you to land your dream job as long as it is related to data science or machine learning. And the concept is quite simple. We involve professionals from all around the globe explaining you the underlying mathematics, statistics, probability calculations, some programming as well, data science, machine learning, and all the kind of techniques that we could use for this. And we will guide you through. And all you have to do is to follow our channel and enjoy the content every second week filled with the real life cases and experts' experiences. And don't worry, we all started from scratch. And we are very happy to build it up from there. You can always stop and rewind the videos or ask for clarification in the comment section. And we hope to assist you on this wonderful journey and have you as a speaker one day. By creating close collaboration with other organizations, we can give the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we would support less fortunate people and organizations that are not that recognized yet, even though they would deserve it. Our organization is sponsored by Microsoft and Myers, and we are humbled by all the support we get from our contributors as well. Thank you, Levante Pongord, for all the beautiful graphical content, and Mina Mari for the cool intro music before our events. We are in close collaboration with C Sharp Corner and Global AI Community, so our lectures are going to be available also on their YouTube channel, additionally to our own media. Nicolette Todd creates and reviews all our text content we use on our websites or advertisements and during our sessions. So please follow us on Facebook, Instagram, and Twitter to become a part of a growing community where we will share knowledge and fun. You will find every information that will bring you to an advanced level in a field of AI and data science. Watch our recorded sessions on our YouTube channel and find our upcoming sessions on our Meetup page. The Code of Conduct outlines expectations for participation in our community, as well as steps for reporting unacceptable behavior. We are committed to providing a welcoming and inspiring community for all. So please be friendly and patient, be welcoming, and be respectful with each other. You can find more information on the link on the slide. And with that, I think we are ready to go back to Paul. Hi, welcome back, Paul.
Okay, thank you very much for all the organization. I know it's a good, very good job, and it's a lot of your time. And thank you very much
We enjoy this a lot.
from the community.
I also thank you for our amazing community because that's what inspires us. This is how it's fun. So today we are going to talk about Azure Machine Learning and Databricks, friends or foe. Paul, are you ready to get started?
Yes,
Then the
ready.
stage is yours. Thank
Let's
you.
go. Thank you. So let's go for the session about the interaction and the differences between two resources in Azure, which are Azure Machine Learning and Azure Databricks. I'm Paul, and I go very quickly on this slide. Just remember the one link, which is my blog. It's in French, but you can translate it very easy. And I will send you on the maybe you will receive it after the session. You will receive a link with my GitHub, and on the one repo on GitHub you will find the notebook with the demo for today and the slides in a PDF format. So this is this animal is the tool which can do everything. In French, we say touche à tout, bon à rien. I think it's the good translation in English. It's all purpose, no purpose, because it's you can't find only one tool to do everything. And in the little story I will tell you, I will try to tell you how I begin from one data set and I go to the predictive model step by step. And this is the agenda for today. Remember that my goal is to industrialize machine learning, or to do what we call now MLOps, personalization for machine learning. I will just define this this concept or buzzword, I think, in a few words, and after that I will go directly to the demonstration with some real data about taxi in New York City. After that, we will look at the interaction between Azure ML and Databricks, and I will show you a big picture with what we call the MLOps stack. It means all the resources in Azure to go end to end from the data storage to the serving. It means to the prediction with a model, machine learning model. Very quickly, if we have enough time at the end, I will speak about Synapse Analytics because in interaction with Azure ML, because you could, well, you would maybe you would make some prediction as a batch in a database like Synapse Analytics SQL pool, and we will see a solution to make prediction in a database. So what's a quick definition of MLOps in six words? It's very important to understand that we want to go outside the laptop of data scientists. We want to run the code for the machine learning in production. It means that we want to automate. We want a real automatization. We want to test new developments. We want to do some continuous integration and continuous deployment. I'm not sure that we want to do continuous training. We could talk about it later, or maybe in the question at the end of the session. But we want to deploy between different environments like development, UAT, and production. So we have to version our code, but we will talk about what we have to version for machine learning in order to make to be able to do some reproducibility. It means that we want to go from the same data, the same data. We want to retrain maybe the model, and we want to find the same prediction at the end. That's I called reproducibility. It's a strong challenge in machine learning because your data could change, your code maybe not, but the library beyond the code could change, and maybe the Docker image where you are making some inference at the end could change too. So it's a very strong challenge. And last word, it's monitoring. You have to think that monitoring, it's maybe you can imagine a predictive endpoint. Like an API, you will ask to the API the prediction for something, and maybe a travel in taxi in New York, but the API could answer to you in maybe less than 1 second, and you could say it's okay. My API is working because I've got an answer very quickly. But it's not the only thing you have to monitor. You have to be careful against data drift, which means that the predictive endpoint gives you an answer, but the answer is totally wrong. I'm not sure that we have time to talk about data drift today, but maybe in another session. So I think that if you are on this channel, you already know Azure Machine Learning, but in a few words, because we begin from zero, from scratch. You have to know that this tool is a portal, a user interface, maybe more for citizen data scientists. You can do some machine learning without code. You can do automated machine learning. It means that you don't have to find the best algorithm by yourself. It's automatically it's done automatically for you. You can label some data like images or text in the user interface, but it's also an SDK. You have a specific language in Python or R. You can do some specific commands to train, maybe to train the model, to register the model, to deploy it as a predictive endpoint. So I think that Azure Machine Learning, it's a tool with many things, but we have to find the right thing at the right moment. And in a few words to Azure Databricks, it's not a Microsoft product. It's available on AWS, Azure, and GCP now. It's the founders of the society. Databricks are the first committers of Apache Spark, but they are they want to take Spark as the heart of the platform, but they add some tools to manage data. It's I'm searching the logo, but it's not on my slide. It's what we call Delta Lake. They integrate an open source tool, which is MLFlow, for tracking of when you train the model. I will demonstrate it later. When you will train the model, you will follow some metrics, some parameters, and after the training, you want to register the model, and MLflow is a model registry too. You can use a tool which is called DBT, specifically for transformation of the data with the SQL language. So it's a very big platform, unified analytics platform. It's the marketing slogan, but we can see on the two pictures that we have two products, and they want to do everything on the life of the data, but we could do better if we interact between Azure ML and Databricks. So let's go for my my real story when I was preparing this this session. I take the well-known data set, which is the yellow taxi travels in New York City. I took the period of 2080 to March of to 2022. It's easy to find the files and download, and it's stored in the Parquet format, which means that files are it's like a zip file. It's compressed and optimized for analytics. And I put my files on Azure Data Lake Gen 2 on a storage account. It's approximately 250 millions of rows. It's not real big data, but it could be too large for my own computer. And I would like to load the data set in memory. That means I would like to work with it interactively. I want to train a model which is just a simple regression. I'm not looking for the performance of, of my model. You will see that the metrics are very bad, but it's not the subject for today. So I will modelize the fair amount of the travel. And with a model, with a trained model, I would like to register the model, and I would like to use it after that as inference. It means I would like to do some prediction, real-time prediction with an endpoint, or maybe batch prediction on tables in a database. So let's go for the my first test. I begin by the definition of a data set in Azure ML. Why not? I think if you are using Azure Machine Learning, it's the first thing you want to do. It's define a data store, define some data set, and after that you will run a compute instance, which is just a virtual machine. And on this virtual machine, you will have Jupyter Lab, and in Jupyter Lab you can load the data. So the virtual machine behind the compute instance is a standard DS3 V2. Just to have in to keep in mind the characteristic of this VM, it's only 14 gigabytes of RAM, and when I try to load 250 millions of rows, it's a memory error. Restart the kernel. The CPU too is in the RAID. So maybe I need to scale up. What does it mean to scale up? It means that I've got just one VM, but I could take in the cloud, I could take a bigger virtual machine. You could do that. It's okay. I'm okay with that. Many people are doing like that. And why do you need to scale up? Because to work with your data in memory, you have to convert the Azure Machine Learning dataset to a pandas data frame. And a pandas data frame is in the memory, in the RAM of the virtual machine. But it means that you need to have but more memory for your virtual machine. So it doesn't matter. I work with a DS3 V2. I can take maybe the DS4 V2. It's 20 gigabytes of RAM. Be careful, it's the price will double. And if you need more memory, take the DS5 V2, but it's double the price doubles one more time. So I'm not sure that scale up is the good way to understand to answer to the issue of memory, of the lack of memory. If you know Azure Machine Learning, you know that we have compute instance, but we have compute cluster or compute target. We can run our code remotely. I'm always in my notebook, and I will run the code on another resource, which are VM2. I begin with the same VM size, but at this time I take four nodes in my cluster. And let's go. But one more time, one error message. It's out of memory. So it's there's a reason for this error, because my code, what I want to do is always to convert Azure Machine Learning dataset to a pandas data frame, and data is always going in the memory of one node of the cluster. So same issue as with the compute instance. My pandas data frame can't distribute on the 4 nodes of my cluster. So I need something specific to distributed calculation, and that's a Spark context. We will go to some resource which can execute a Spark context. If you want a Spark context in Azure, I think the easiest way today is to create a workspace Azure Databricks. So let's go and start the Databricks cluster. I will explain to you how to authenticate to Azure ML workspace later, but for my Databricks cluster, it's also standard ES3 v2 VM, but I've got 2 VM. We call what we called a worker and a driver. The driver is going to say what the worker has to do, but it's with many workers, it could distribute the calculations, the data and the calculations. So remember that I would like to do dataset to pandas data frame. I've tried to do to use the method to Spark data frame. I think it's okay because I'm in a Spark context, I'm in Databricks, and I could create what we call Spark data frames. Spark data frame are not in only one node memory. The data is distributed against all the nodes, but it doesn't work. I've got one issue, and I read some post on Stack Overflow. I think it should work with a version of Scala, which is 2.11, but you have to know that it's a very old version of Scala in the what we call the Databricks runtime, and we have the issue on the last version, which is 2.12. So it doesn't work. The method got an error. So the conclusion is that I can't read the data from the data store. So in Azure Databricks, I can't, even if I can connect to Azure ML, I can't read big data from a data store by if my way is to go through Azure ML, I can't do that because it doesn't work. The to Spark data frame method doesn't work at the moment. So first conclusion, we have to forget the Azure ML data stores and datasets. We will work differently. And now I'm trying to let's go just on the Azure. I go to the demo, the real demonstration. I'm here in my Databricks workspace. I got one cluster which is started, and on this cluster I can read my Parquet files, which are here on the what we call the mount point. It's my data lake, Gen 2, and it's a folder. It's many folders on my data lake. So I give the pass. I read all the Parquet files, and it doesn't matter here. It's okay with all the data. I can have just a display which is just the first 2,000 rows of the Spark data frame. I can have the schema of the data frame. I do some data cleaning because you know, if you take if you do a trip with a taxi, you can't have negative numbers for the distance. You can't. I hope that you can't pay much more than $50,000 for just one trip. But I do some data cleaning, and after that, I would like to train a model. So now it's okay. The data is in memory on my cluster, and now I would like to train a model. But going back here, if I want to use something that everybody knows in machine learning, which is scikit-learn, if I want to work with scikit-learn to train a model, I need to convert my data to a NumPy array. So it's the same issue as with the pandas data frame. All the data is going in the memory of the driver. Remember that in the cluster we have one driver and 1 or 2, 3, 4 workers. If you convert to NumPy array or pandas data frame, all the data distributed on the cluster is going to the driver node, which has only 14 gigabytes of RAM. So one more time, the out of memory error. So we have to use not scikit-learn but Spark libraries to do some machine learning. If you remember of Spark, I think version 1 and what we call the RDD, it was before data frames we work with RDD, resilient distributed data set. We had a library which was called MLlib, but now in Spark 3 it's obsolete. We could think about Spark ML, which is the library since Spark version 2. But what about an open source library which is which come from Microsoft research, which is called Synapse ML. I will show you that it could be a good idea if you want to train model on big data. So, in a few words, what is Synapse ML? Maybe you could know this library on the old name, which was ML Spark, Microsoft Spark ML or something like that. So it's a library built on the top of Spark ML, and because it's Microsoft, you can interact with some Azure Cognitive Services, but you can do some, you can use OpenCV for computer vision. You can use LightGBM. I will talk about LightGBM just after this slide, and you can use one model format, model framework, which is ONNX, and I will explain you what is ONNX later. Very easy to install this library on your Databricks cluster. Just a Maven library to download, and we will use for my I want to modelize the fair amount of the trip, so it's just a linear regression, but I could use maybe one tool like LightGBM, which is an open source library, an open source framework based on the gradient boosting, which is maybe faster than Spark ML, which is cross-platform. You can do it with some Spark, PySpark, or Spark layer, and you can do all the all the tasks in supervised machine learning, which is in classification or regression. You can do some ranking, with this library. So it could be very an interesting tool to train the model. But at the end of the training in Databricks, I would like to go back to Azure ML. Why? Because I want to register the model and I want to deploy it maybe as a predictive endpoint or to use it for some batch prediction in database. So if I stay with the Spark ML framework or the Synapse ML framework, I can't do that in Azure ML or in a database. So I need I will need to convert my my model in another framework, which is ONNX. It's a project, an open source project. At the beginning, it was Facebook Research and Microsoft Research who work on this project, and the goal is to have only something which is interoperable between all the frameworks in machine learning or deep learning. So you will convert your model from this frameworks. You will convert it to ONNX, and we will see that Azure ML and Azure Synapse Analytics can use this ONNX framework. So I'm going back to my notebook, and here I import the Synapse ML library. Okay, train test split. Okay, and it's just I begin by just a linear regression. I'm not working at the moment with LightGBM, but I would just want to try this this library. You can define some hyperparameters, and it's like in scikit-learn, maybe you will fit the model on the training data set. You can save the model like that in here on the data lake, and you can score the model. You can do some prediction on the test data set, and you can compute. You can evaluate the model with some metrics like the traditional metrics for regression. I have told you that it's very, very bad values for my metrics, but it doesn't matter. So it was just one first try with Synapse ML. Now I take the LightGBM regressor in Synapse ML, and I will train again the model. I have to build a featureizer, which is one. Maybe I could show you here. All my features is only in one vector. Okay, it's easier to work with this this kind of groups of features. I've got the target, the features in one vector, and I could have the prediction. I define my model. I will define some hyperparameters. Okay, and I can get the feature importance. It's very, very easy. And have a look at the chart here, which gives me the feature importance. It's very, very easy to find that the amount of the trip is more correlated to the trip distance than the passenger, the number of passengers in the taxi. So I will save the model one more time, but at the moment it's not in the ONNX framework. it's the model is in the LightGBM framework, and I would like to do something more more easy easier to integrate in Azure ML or Synapse Analytics. So I have to convert my model to ONNX. The most important part of the code is here. I've got to use a library which is ONNX ML tools with the converter, and I have to define a tensor. That means I have to define the types of the input for the model, which will be the input for the predictive endpoint when I will make some inference. And now I can save the model as a ONNX, a real ONNX model here. Just one quick tip, trick here. The model you have to save the first time you have to save the model locally. You can't save the model directly on the data lake. I have to save it on the driver of my Databricks cluster, and after that, I can copy it to my data lake. So just one little trick here. Okay, I've got one ONNX model, and now I can register my model on Azure ML. And now I'm going to work with Databricks and Azure ML. I have to authenticate on this workspace, and I choose to work with a service principal to authenticate it automatically. If you are working with the interactive authentication, you can't go to your notebook and do the authentication, and after that your notebook will stop at this command. So you have to work with some SPN and work with service principal to authenticate automatically. And now I can use the Azure ML SDK, and I can register my model. I give here the model framework. It's ONNX because it's something known in Azure ML. Azure ML can work with scikit-learn's framework, with TensorFlow, PyTorch, and ONNX. So it's okay. I've got the right framework for model registering in Azure ML. I give you very quickly an example of prediction with ONNX runtime. So I load the model from the file here, and I've got to give my new data like an NumPy array, and so I run here the prediction, and I can you can see that for this value input values, I have to pay $6 for the trip. Okay, so I will just make a little summary of what I do here, because I would like to point some limitation in Databricks. I will talk about MLFlow to register the model, and to maybe to do some serving. It means that I want to have a predictive endpoint, and Databricks could do that. There's one service in Databricks which is MLFlow, and we can register the model in MLflow. We can do some serving. We can run a virtual machine and define a predictive endpoint. But if I do that, I think it's not a good idea, because MLflow is inside your Databricks workspace. So it means that you have to manage the stage of the model, staging, production, inside one resource, which could be maybe in the development environment. I think it's not a good idea, because we want to do some isolation between environments. We want isolation between development and production. We don't want only one workspace. We will maybe work with one workspace, one Databricks workspace for development, one Databricks workspace for production. So we need to externalize the model registry. And for serving, I prefer the tools in Azure Machine Learning, like container instance, web app, or Kubernetes service, because with Databricks, I have no, I can't monitor the predictive endpoint. There's no real authentication for this endpoint, public endpoint. I can't fine tune the resource, and I will pay for the run of the virtual machine with the DBU cost, Databricks unit cost, which means that it's it's expensive, it's a little bit expensive, and it includes the Databricks license when you run the virtual machine. So I would like to say here that you have to take the right part of the tool, and don't use everything in Azure ML, but don't use everything in Azure Databricks too. You have to pick up to choose the right thing. So to store the data, I think it's not a good idea to use, if you work with big data. Okay, it's not a good idea to define some data store and data set in Azure ML. You will prefer some Parquet files or Delta Lake files in a real Azure Data Lake. Use your compute instance in Azure ML just to run a notebook or Jupyter Lab and notebooks, and just make some exploration on your data, but it's not the code you will send to production. I'm not sure that compute cluster is a good idea, because it's really hard to distribute the code on the compute cluster, because you don't have any Spark context on that. And talking about environment, development versus production, you don't need one workspace, one Azure Machine Learning workspace per environment. I will show you a schema with that later. So Azure Machine Learning must be central to the architecture, and I will show you that. And the advantage of thinking of a centralized registry is that you will log all the experiments in one centralized resource. You will make some tracking for your models. You will register your models, and you will deploy the predictive endpoint from this central resource. So in this traditional picture about Azure ML, forget about data stores, forget about compute cluster, but keep only the registries services in Azure ML. Just I forgot to show you the no, I don't forget to do that. It's after that in the slides. MLflow in a few words. With MLflow you could log when you train a model. You could log some hyperparameters. You could log the metrics. Here it doesn't work, but it doesn't matter. But you could log the metrics, and you could log the model. You could register the model, and it's the result is here. For example. It's not the same model. No, sorry. It's here. Okay, taxi. Okay, that's it. Here I save the model with MLflow inside my Databricks workspace, and I've got one ONNX file. I've got all the dependencies in YAML file, the requirements for this model, and a definition of all the model in this YAML file. So it's what we call the artifacts, and it's all this package in this this tool, which is MLflow, hyperparameters, metrics, etc. But my advice is to put all this information on Azure Machine Learning. So I go back to the notebook, and I will define what we call the tracking URI. If you work by default with your Databricks workspace, sorry, it's just here. When you work with your Databricks workspace, the tracking URI is the workspace himself. But you can link your Databricks workspace with Azure Machine Learning. So I can get another tracking URI, which is which comes from my Azure ML workspace. This is my Azure ML workspace here, and look at the URI. We can see that it's okay now. We are logging everything on Azure Machine Learning. So when I run my training, everything is all the logs are going to the Azure ML portal. Here is the experiment, and we go on this one, and I can find here all the files, but they are not in my Databricks workspace. They are going to a centralized resource, which is Azure Machine Learning. So I will just show you now to go a little bit quicker. I will show you what we call the MLOps stack. Here, it's based on a very interesting website, which is ml-ops.org. All these people have think about a stack for machine learning in production, which some steps with some pipeline, data preparation, data engineering pipeline, which means the preparation, cleaning, etc. The machine learning pipeline, that's the training, and the serving. We want to expose the predictive endpoint, and we need for that we need some registries. We need to register and version the code. Maybe we could register use a feature store. Maybe we talk during the question time, but you can register the transformation on all the feature coming in the model. We register the model like in MLflow, and we have some tracking information, metadata here. So if I take this this schema, and if I do some some adaptations. It's our version in Avanade of the MLOps stack. You find here the three main pipelines and all the registers we need to work and to go end to end with our data. Now applied with real Azure resources. I will work with Databricks linked to my data lake for data engineering. I will train my model on Databricks, and I will use Azure Machine Learning to do some serving, to maybe to put my model in a web app. And to do that, I need some registries. I will use the repositories in Azure DevOps. I will use MLFlow, but remember it's the MLFlow linked to Azure ML. And maybe I will use the contour registry for Docker image, which is the final image for prediction. And all of the monitoring could be done with some Azure resources. If we are thinking now on different environments, we need one Databricks maybe as a sandbox here in the development stage. We could register the model on the data flow, and in production we could upload download. Sorry, we upload from the development and we download from the production environment, and we can run. We can train here and run the model at only in the production environment, but it's not. It's one idea, but you could retrain eventually. You could retrain the model with all the data in production, but there's no one way to I think to do MLOps at the moment. So how to summarize the demo, how to authenticate between Databricks and Azure ML. Use a service principal, define the tracking URI of Databricks with the Azure ML workspace, and there's a magical button in your Azure portal. You can link automatically Databricks to Azure ML, and after that you will find the name of the Azure ML workspace. And after doing this operation, you can get the tracking URI of Azure ML and define it into Databricks. You could another way to interact between the two resources is to define what we call an attached compute. I'll go very quick for this one because I'm not sure it's really useful, but it's good to know. If you work with Azure ML pipeline, you know that you can define some steps. You can cut your code into steps, and if you need the Spark context, if you need to work with big data for maybe one step, you could launch, you could run a Databricks notebook inside the step with this Databricks compute defined in Azure ML. But it's just another way to orchestrate all the steps of the end-to-end pipeline. And I talk about ONNX, and it's a good news because Synapse Analytics can use my model now. I will go very quick and look at the slides if you want to have more explanations. But with we go on that directly. You can link Azure ML and Synapse Analytics. And after that, you upload the ONNX model from Azure ML to Synapse table. Here is the ONNX files is now in a table in the database. And at the end, you can use one T-SQL function, which is predict. And so you can call here the model storage. You can call the model and have an output as a prediction on your data, which are stored in a table in the database. So it works because I convert my model to ONNX. So in conclusion, main differences between Azure ML and Databricks. Use Databricks if you have a very big volume of data, if you can't work in memory with Pandas data frame or scikit-learn. You are going to scale out and you could scale up, but it could be a good idea to scale out. And between Azure Machine Learning and Synapse Analytics, Synapse is more for batch scenarios. If you have to make some prediction in batch, but it could interact too. You can call import a model stored register in Azure ML. You can call this model, import it, and call it in a table of Azure Synapse Analytics. So I think it's a good idea to have a look at the ONNX framework. And in conclusion, so it's not a real conclusion of this talk, but some tips to save money with Azure. But maybe I will look at the question in the chat and let you a few minutes to have some discussion about this session. Thank you very much.
Wow, Paul, that was a really interesting and a lot of information.
I
But
could
it was
have
nice to no, but it was nice to see all these tools working together. And we have a few questions actually. We are also going to share your blog in the chat in a second. And we had a question about whether the notebooks and the code that you were using are available for the audience.
Yeah. The code is on a public repo. I don't know if I can put it in the public chat.
You can put it in our private chat and we
Okay.
share it away to the audience.
Okay, here is the GitHub repo.
So you were also talking a little bit about the costs of these services, but if someone just about to get started with this and would like to build an amazing pipeline, including all the data preparation and modeling using all the tools that are available from the Azure stack, is there like a free tier of these services to try out?
No, you can't. If you're thinking about the Azure Cognitive Service, we have free tiers for the first try we do with these services. But here when you train a model or when you do some data preparation, you have to run a virtual machine, and virtual machine is always a cost in Azure. But you can, if you have a very small amount of data, if you have small data and it works on your laptop, you can download, you can install the Azure ML SDK, for example, and can work on your laptop with this SDK.
Thank you, Paul. We also showed us that when we are building a pipeline, it makes sense to run the data preparation and cleaning inside Databricks. And even though you would be able to run the machine learning modeling as well in there, it is a good idea to run it in Azure ML. My question goes for that. Are you able to run an experiment in Azure Machine Learning by running a code inside Databricks
Um, yeah,
using the Azure ML SDK possibly?
yeah, yeah. You can install the Azure ML SDK on the Databricks, and you can interact with all the components of Azure ML from Databricks. And I think it's a good idea because my advice is to, my opinion, I think today is to keep all the data preparation and training into Databricks, because when you have big data, you can't do you need to work with Spark. So work all the data preparation and training in Databricks, and after that use only Azure ML for model registering and model serving. It's uh, a clear split of the task, I think.
Thank you. And when it comes to Synapse, you are building it like a pipeline. It's a similar setup like in ADF. I'm not a very familiar person with Synapse yet, but is it also available to run only the notebooks of Azure Machine Learning from Synapse, or you need to run the pipelines straight?
Um, so we are talking about Synapse Analytics, so
Yes.
and not the Synapse ML library. Uh,
Yes,
yeah, it's a little bit confusing because everything is
it is
called
confusing.
Synapse. But in Synapse Analytics, you can run a Spark, what we call a Spark pool. You have, if you remember about Azure Data Warehouse, Azure SQL Data Warehouse, you have a SQL distributed SQL pool, and now in Synapse Analytics you can run a Spark pool, and you can run notebooks inside the UI of Synapse Analytics. So it's an alternative to Databricks, and um, and you can install the Azure ML SDK too, and you can interact with Azure ML. So it's another way of doing the same thing. I think that my first mm, my first reflex is to work with Azure Databricks, because um, um, maybe it's I, I think it's I've got more tools to do some CI/CD. It's easier to deploy the notebooks from one Databricks workspace to another one, rather than with Synapse Analytics. But it could be a real alternative between the Databricks and Synapse.
Thank you, Paul. Um, and I'm not sure if we have any other questions. If there are questions from the audience, please put it in the chat. And with that, I hope that you all enjoyed this session. It was really cool. Thank you, Paul, again for your time. And we also hope that we will see you soon again. And please don't leave the studio for now before I just get a few side notes in the end of the session. So, and your journey doesn't need to stop here, because we are going to send out some post-session information on Meetup and on Twitter too. And I'm going to post in the comment section that please provide us some feedback so we can improve our sessions for the next time. And the next time we are coming back in the end of June, where we bring back all our speakers from this semester, and we're going to talk about all the tools that you have seen in the past few months and see how these are helping you to bring value into your own workplace as well. I think it's going to be very interesting as well. So I hope to see you back in the end of June. For that, please follow our meetup page and our Twitter, and let us know if you have any more questions. Thank you a lot.